Dependent and independent events. Combined events where the outcome of one event affects the other event are called dependent events, like conditional probability. When the outcome of one event does not affect the outcome of the other event, these combined events are called independent. Actually, we have to be just a bit careful there. If events are independent, then knowledge that B occurs or not will have no effect on the probability that A occurs. So, the probability of A given B is now the probability of A. Knowing that B has occurred does not change the probability of A. If this is the case, then the probability of A intersection B is equal to the probability of A given B multiplied by probability of B becomes probability of A and B is just probability of A times probability of B. And that's because here we're just replacing probability of A given B by probability of A. This can be used both to calculate the probability of A and B for independent events and as a test for independent events. In other words, if we know probability of A and probability of B and we know that the events are independent, then we can calculate this. On the other hand, if we want to test whether events are independent, we can calculate this and see if it's equal to this. Now, let's just look at an example which may clarify what we're talking about here. So I've got a sample space here, and we have events A and B, and because it's an easy example that works, I'm going to say that there's 3 outcomes in each area. So if you look at the probability of A, there's 6 things in A out of 12, so the probability is a half. If we look at the probability of A given B, then B now becomes the sample space because we know it's happened. There's now 3 ways that A can have occurred. It has to be in the intersection out of the 6 things that can occur. So the probability is still a half. And we would say that these are independent events because the probability has not changed. So, probabilities unchanged, the events are independent. But note, A itself has been affected. Since we know that B occurs, these 3 outcomes which are in event A cannot have occurred. Only these 3 can have occurred. So the outcomes from the event itself are affected, but the probability is not affected, and that's the definition of independent.